In this video, we're going to talk about section 6.2, vertical stretches and shrinks. So if we look at this white function y equals f of x, you can see it goes from -1 to 1 on the x and also -1 to 1 on the y. And then we'll talk about what these different numbers on the outside of the function do. So a 2 on the outside is going to multiply all of the y values by 2. So that's going to make the highest point, which is 1, be twice as tall. We're going to multiply that by 2. And also the lowest point, which is -1, will get multiplied by 2 and go down to -2. The x values will be unaffected. So we plug in -1 into our function. We get f of -1 is 0. So 0 times 2 is still 0. And then at a half, we're going to be up to 2. And then down to 0 again, all the way down to -2, and all the way back to 0. So we would call this a vertical stretch. The y values get stretched, they get multiplied by 2, and the x values stay as they were. So when a number in front of the function is smaller than 1, then all of those y values will get multiplied now by a half. So they're going to be half as tall. So we're going to, at 0, it's still going to be a half times 0 is 0. At a half, instead of being all the way up at 1, that y value of f of -1 is 1 times the 1/2 is back to a half. And at 0, we're 0. And then at 1/2, we're down to -1/2. Then back to 0. The shape stays the same, so we'll call that a vertical shrink. And on the blue function, we have two things going on. We're going to get the negative is going to reflect it in the x, and the 2 is going to stretch it. So we'll be at 0 at -1. Then at half, we'll be all the way down to a -2, and then back to 0 at 0. And similarly, we'll be up to +2 when x is a half, and then back to 0. So you see a reflection and a stretch both. On the red function, we're going to see the reflection because of the negative, and we'll see a shrink because of the 1/2. So again, at 0, we stay 0. At a half, we're going to go down to -1/2, back to 0, and then back up to a half, and then back to 0. So everything gets shrunk vertically by a half. So to summarize, if we have y equals k f of x, then if k is bigger than 1, that means we're getting a vertical stretch. And if k is between 0 and 1, then we're going to get a vertical shrink. And I think that's pretty intuitive. The horizontals are a little tougher. We'll talk about that next time. So let's revisit our rate of change and see what happens when we have a stretch, and then we look at what the rate of change does. So first, let's just plot some points here. Here's our square root function. At 0, square root of 0 is 0. At 1, we get 1. And when x is 4, we get square root of 4 is 2. So it's going to be that top half of a sideways parabola. So looking at the rate of change between 0 and 1, we're going to do the square root of 1 minus the square root of 0 over 1 minus 0. Remember, that's our change in y over change in x. So that's going to be, in this case, just 1. So the rate of change between these 2 points, that is the slope of the line connecting those 2 points, is just 1. For 1 and 4, we're going to get square root of 4 minus square root of 1 over 4 minus 1. Square root of 4 is 2, square root of 1 is 1, so we're going to get 1/3. So if we look at the rate of change between those 2 points, you can see that the rate of change has decreased. And if you remember, when the rate of change is decreasing, we say that that means the function is concave down. Okay, so let's see what happens now when we do a vertical stretch. So I'm going to plot some points again. At 0, we still get 0. Square root of 0 is 0 times 2 is still 0. Now when we plug in 1, we're going to get the square root of 1 is 1 times 2 is up to 2. And when we go out to 4, we'll get the square root of 4 is 2 times that 2 is going to put us up at 4, 4. So it's kind of looking like this. Remember, there's still going to be like a sideways, the top half of a sideways parabola. So now our rate of change between 0 and 1, we're going to get 2 square root of 1 minus 2 square root of 0 over 1 minus 0. So that's going to be 2 times 1 minus 0 over 1 is 2. So we see that the earlier rate of change gets multiplied by that 2. So it becomes twice that. And let's see if that also works with when we move to 1, 4. So 2 square root of 4 minus 2 square root of 1 over 4 minus 1. Square root of 4 is 2 times 2 is 4. Minus 2 over 3 is going to be 2/3. And you can see that there again, it multiplies that rate of change by that k, that number that's multiplying the function. Okay, so let's I'm going to slide this up a bit. So let's combine our stretches and shrinks vertically with our translations, moving this thing right and left. So here's our parent function, y equals square root of x, is that yellow function. So if we go to multiply by 2, and then we're going to move it right 2 and up, or right 1 rather, and up 2. So the y value here is 0. That gets multiplied by 2 and is still 0, and then it gets moved up 2. So I'm going to go up 2, and that's going to be at 1, and that's going to be our point right there. And if we put in 0, then we're going to, well, when it's 0, so that's going to actually, I didn't do that right. Let me back up. So in order to evaluate f at -1, we have to choose x to be 0. So, or maybe let's do it this way. We're going to stretch it. Let's just look at it more universally. So the 2 is going to stretch that. So everything is going to be twice as tall. And then we are going to move everything right 1 and up 2. So I'm going to draw maybe, I'll show you the in-between step here. So multiplying by 2 is going to stretch that vertically. And then if we move everything right 1 and up 2, this point is going to go right 1 and up 2 is going to be here at 0, 2. I'm going to have to extend that up. And this point that was at 0, 2 is going to go right 1 and up 2. So it's going to be up here at 1, 4. And this point that was at a half, I didn't do that right. So that's really at, that point was at, let me go back. So this point is going to go over 1 and up 2, so that's going to be at a half and 4. And the origin is multiplied by 2 is still there. Over 1 up 2 is going to put it here at 1, 2. Our point here that's at a half, -2 is going to go over 1 and up 2. So it's going to be right here, halfway between 1 and 2. And this point right here is going to go over 1 and up 2. It's going to be there at 2, 2. And so we'll connect those, and that's going to be our stretched and translated curve. So the next one, now we're going to reflect it in the x, stretch it by 3, and then move it left 2 and up 1, or left 2 and down 1. So let's see what the reflecting and stretching does. So let's mark this up. We're going to stretch by 3. So instead of going up to 1, we're going to go up and down to 3 and negative 3. So our reflected and stretched curve is going to look something like this. And then we're going to move that left 2 and down 1. So this point is going to go left 2 and down 1. This point is going to go, let's see, it's going to go left 2 and down 1. It's going to be right there. And this point is going to go left 2 and down 1. So far we're looking at this. And this point is going to go left 2 and down 1. And this point right here is going to go left 2 and down 1. So we're going to get, where did that point go? We are going to be something like that. And this high point, it's kind of hard to tell there. I moved that over left 2, so that's going to be, here we were halfway between 0 and 1, and so we are going to be between negative 2 and negative 3. Whew, that's tougher. Okay, let's do some square roots. So our parent function here, our square root of x, let's take a look at that, is going to look something like this, and we know that it's going to contain the point 0, 0 and the point 1, 1. So our square root inside the function is going to be a reflection in the y, so we are going to get something that looks like that. The negative on the outside is going to reflect it in the x, so that's going to make us go through the point 0, 0 and 1, negative 1. And our double reflection, we're going to reflect in both the x and the y. So let's kind of do that one step at a time. So here's our original parent function, square root, reflecting, it doesn't matter which order you do it in, reflecting the x goes here, so and then reflecting that in turn in the y is going to make us go through those points and go down and to the left. Our 2 square root of x we've seen is going to be vertical stretch. So on the original, we went through the point 0, 0 and 1, 1. And so we'll still go through 0, 0, but now the y value is going to get multiplied by 2. So it's going to be a wider opening top half of a sideways parabola. And on the negative 1/2 square root of x, we're going to get, so the negative is going to reflect it, and the 1/2 is going to shrink it. So instead of going from 0, 0 and going down 1 over 1, we're going to go over 1 and down 1/2. So the y value is going to get multiplied by a negative 1/2. So it's going to look something like that. I think we got more. Nope. Let's go to the next panel. So now we're going to take a look at what happens with these things when we have functions that are given as tables. So here is our function, and we have the x values and the y values, and now we're going to try to evaluate f of negative f of x. So we're going to plug in the negative 2, and that tells us we get 5, and then we multiply that by negative 1, so it becomes a negative 5. When we plug in negative 1, we get 3. That gets multiplied by negative 1 and becomes negative 3. When we plug in 0, we get 0, and multiplied by negative 1, that's still 0. Plug in 1, we get negative 3. Multiplied by negative 1 is positive 3. And similarly, we get to here. So the question we're also going to try to answer is which of these are odd functions. Remember, what it means to be odd is f of negative x is the negative of f of x. So we can see in the original that when you plug in -2, you get 5, and when you plug in 2, you get -5. So when you plug in, say, f of -2, you get the opposite of f of 2. And because here we would have gotten 5, and here we get the negative of that -5. The negative of 5, rather, sorry. Okay, so here f is in fact going to be odd, and in the case here it's also going to be odd, so negative f of x so far is also odd. Now plugging in the f of -x, so if we plug in -2, then what we actually evaluate is f of +2, and f of +2 is -5. When we plug in a -1, what we actually evaluate is f of +1, that's going to be a -3. And plugging in 0, f of -0 is still the same thing. And plugging in +1 makes us evaluate f of -1, which is +3. And plugging in +2, we evaluate f of -2, which is 5. And you can see that when you plug in -2, you get the opposite of what you get by plugging in 2. So this also is going to be odd. So f of -x is added to our list of odd functions. Now this one's where it gets a little trickier. Now we can only evaluate f at these values of x. So we have to choose a value of x that when we plug it in and subtract 1, we get something we can evaluate. So if we want to evaluate at f of -2, we're going to plug in -1. So when we use x as -1, what we evaluate is -1 minus 1 is f of -2. And according to our table, f of -2 is 5. Now if we plug in 0, then we evaluate f of 0 minus 1 is -1, and f of -1 is 3. When we plug in +1, what we evaluate is f of -1. We plug in +1, what we evaluate is f of 0, which is 0. And when we plug in 2, we evaluate f of 1, and when we plug in 3, we evaluate f of 2, and we see this. Now what we see is this is no longer going to be odd, because when you plug in -1, you get 5, but when you plug in +1, the negative of that, you don't get a -5. So that's no longer odd. Let's look at the next one. Now here, if we plug in a -2, we get f of -2 is 5, add 1 is going to be 6. When we plug in -1, f of -1 is 3, plus 1 is 4. When we plug in 0, we get 0, plus 1 is 1. When you plug in 1, we get -3, plus 1 is -2. And when you plug in 2, you get f of 2 is -5, plus 1 is -4. And now also, we're not getting odd because when you plug in -2, you get 6, but when you plug in +2, you don't get the negative of that. Okay, do I have more on this panel? Oh, I do. Okay, now these are the ones where it gets tricky. So our domain for some unknown function p of n is -n, or -4 to 6, including the -4, but not including the 6. The y values, the range, go from -10 to +8. So can we come up with a function in terms of p of n of something that has this domain? Well, it looks like the domains are the same, so that means we're not going to plug in anything here that would change our domain. So that's still going to be a p of n. Now we look at this and we have to figure out, well, what are we doing to our starting range to get there? And you can see that this is no longer an or equal to, so we must have switched the order of this. we must have somehow multiplied through by a negative to make this be a 10, switch the inequality, and then switch the inequality there. And then if I write them from left to right, that's doing something like this. But it looks like it also, let's see, if I multiplied by -1, that would have been a negative. But then we also must have divided those by 2. So that means we must have multiplied our y values by a -1/2. Does that make sense? Kind of? Now, the next one, the yellow function, now we've got the range has been switched. And so that means we must be getting p of -n. So we're multiplying the x values by -1 to change that domain to -1 times what it was. Now the y values are, we haven't switched the order of these. We still have the or equal to first. But let's see, from -4, the lower limit there, to -10, how are we going to get to there? Maybe we added 6, or maybe we subtracted 6. Because if we subtract, from here to there. So we added 6 to -10, that would take us to -4. And if we added 6 to the 8, that would also get us to 14. So I think we added those y values by 6. Tricky stuff. Now we're looking at the next one, the green one. Well, our domain looks exactly the same, so that means we aren't doing anything inside there to change it. But now let's see, how do we get to -22 starting with a -10? If we multiplied it by 2, that would be a -20, and then if we subtracted another 2 from that, that would get us to -22. Let's see if that works for the 8. If we multiplied it by 2, that would be 16. And then if we subtracted 2 from the 16, that would give us the 14. So it looks to me like it's 2 times those y values minus another 2. Tricky stuff.